So what we're going to do now is an exercise, and if you download the presentation, you can get the data. You'll have a link to get the data for this exercise. And this exercise is based on table 5.2 of King, of one of the references texts that we're using. And the proposal here is to do a small exercise of reconstructing a cohort and follow this cohort in terms of biomass and numbers through time, right? Using very basic functions of growth. And in this case, you have the parameters for K, the growth rate, and L infinity, the maximum size that the fish will, the asymptotic maximum size for the fish cohort. You will also have the natural mortality. The natural mortality is also given, estimated. We don't need to know how. And you also have weight, the weight length relationship given. And what is proposed is that you do calculate the length of the fish with age, and then from there to calculate the weight, and then use the exponential decline function to calculate the relative numbers of fish, and then have an estimation of biomass. Right. So I'm going to change here to the Excel where I have, here you go. I think it's this one. No, it's this one. I don't think I'm sharing the right screen. Let me see. Okay. So here it is. Let me increase this a little bit. Okay. So when you download the data, you will get a spreadsheet like this. And this spreadsheet already has the variables, the parameters given by King in his table 5.2. And you also have then the table that you need to fill. And this table, so it tells you, it asks you to reconstruct the cohort in terms of the age of the fish from 2 years until they are 12 years old. And so what you will do, as I said, is to calculate the length that each individual fish will have 2 years, 3 years, 4 years, and so forth. You will calculate from the length the corresponding weight of each individual fish. And then, of course, an important thing is how many fish there are if you want to calculate biomass of the stock. Well, we don't know that, and so, but we must do something about it. And so one alternative is to use relative numbers. So, and in this case, we're going to say, okay, we're imagining that we will start with 1,000 fish, and then we'll see how many fish are left in the 3rd year and the 4th year and so forth. And we're going to use this equation for the exponential decline function. And then once we know the individual weight of each fish, and we know how many there are, even if relatively, we can calculate stock biomass. So what you will have to do is just put the formulas that are here in your table. So let's start with length, right? So length is given, length of the fish at a certain time is given by the von Bertalanffy equation by multiplying L infinity by an expression which is 1 minus t raised to the power of minus k t. If you would have, let's forget for a moment t0. We neglect t0, so we'll say that t0 equals 0, so we just forget about it, and then we'll have just e raised to the power of minus kt, right? So there you go. We just need to put that formula here. So it equals L infinity, and I have added names to the cells to make it easier to understand the formula. So that would be L infinity times 1 minus e to the power of minus k, where is k? Here, okay, times t, and t in this case is time, so it will be h, right? And I'm closing this parenthesis and this parenthesis, and it's done, right? And you can look it up in King's table to see if the numbers add up, and they add. Now, so a fish with 2 years will be 32.97 centimeters on average. There will be larger fish, there will be smaller fish. This is the average size of the fish. And their weight will be given by this formula here, which says that the weight equals this coefficient times the length raised to the power of 3. Oops, there's something wrong here. So let me start again. Equals this, equals, sorry, equals this coefficient times length, which is this one, to the power of, in this case, 3. Okay, so each fish will be 33 centimeters long and will weigh on average 200 and almost 300 grams, right? And there will be 1,000 of them, right? So the stock biomass will be 194 grams times the relative number of fish. And because we want to give this in kilograms and weight is in grams, we'll have to divide this by 1,000. And there we go. Right. Now, there is one thing that is missing, which is to calculate how many fish there will be next year on the 3rd year, because of course, these formulas can just be pulled down, because and you'll get to know immediately the size of the fish, the length of the fish for each year. And then, of course, you can also extend the same equation, same weight equation, because it only depends on the length. So you will know that fish at 12 years will be almost 1 meter long and will weigh more than 6 kilograms on average. Now, what happens to the numbers of fish? You'll have to use the exponential decline function for mortality, right? So in this case, the number of individuals when they are 3 years is equal to the number of individuals with 2 years multiplied by e raised to the power of minus the mortality rate. And that will be 644. Now we can extend this equation down, and we will see that by the end of the 12 years, with this mortality rate, there will be only 12 fish for each of the 1,000 fish that we started with at 2 years. So let's say the recruitment happens at 2 years, and for each 1,000 recruits, only 12 on average are alive 10 years later, right? And of course, the stock biomass increases from year 2 to year 3, although the number of individuals has decreased from 1,000 to 644, because they're much heavier. The stock biomass increases, almost doubles, right? Now, for year 4, it's still increasing. So the number of animals continues to decrease because they're still dying, but because they're still growing and they're growing fast, the stock biomass continues to increase until it starts decreasing, right? The fish are still growing, but they are growing slowly, and now mortality is catching up and overcoming growth, and the stock biomass starts declining from here onwards, right? So try this exercise, and then the next step is to do graphs with this. And there is let me go back to the presentation here. Let me go back to the presentation. Where is it? Here. And you are expected then to build this graph, right? Taking the values of numbers of animals, biomass, and individual weight, and you can try to do that using your data. Build this graph where you will see what I have just mentioned, right? So the fact that individual weight is growing constantly, although very fast in the beginning, and then slowly and slowly as the animal gets older. But the number of individuals surviving decreases exponentially, so very, very fast in the beginning, right? And as a consequence, the biomass increases in the first years, and then decreases in the years that follow. And that's it for today.